Good morning, respected sir. I'm Sujana Tabassum. This is the title page of our Discrete Mathematics mini project. It shows the project title, the name of our course teacher, Dr. Nafis Sadeq, and the names and ID numbers of all group members. This page introduces our project formally, and now I will move to the agenda slide. This page presents the agenda of our presentation, meaning what topics we are going to cover. According to the agenda written here, the project is divided into two main parts. Part A2 is focused on binary search, where we analyze its empirical time complexity. Part B2 focuses on followership graph analysis, where we work with directed graphs and analyze their properties. The agenda also mentions discussions, conclusion, and key findings, which shows that the project follows a structured analytical approach. This page contains a graph showing the empirical time complexity of binary search. The graph plots array size on the x-axis and average search time in milliseconds on the y-axis. As explained in the project, the graph shows that even when the array size increases significantly, the execution time increases very slowly. This behavior visually supports the theoretical O log n time complexity of binary search and shows why it is efficient for large datasets.
Hello, this is Sadman. This page contains the introduction and methodology of binary search. According to the explanation written here, binary search is an efficient algorithm used to find an element in a sorted array. This page explains that its theoretical time complexity is O, which makes it faster than linear search for large datasets. In the methodology section, it is written that binary search was implemented using Python 3.9 following an interactive approach. The experiment used array sizes ranging from 10,000 to 50,000, and for each size 1,000 searches were performed. Execution time was measured using time.perf counter, and the experiment was repeated multiple times to ensure accuracy and statistical significance. This page gives the discussion and conclusion of the binary search experiment. As written in the PDF, the experiment result shows that the time increases in a logarithmic way. This matches the theoretical O time complexity. The explanation says that even when the input size becomes very large, the execution time increases only a little. This proves that binary search is very efficient. If there are small differences in the results, they may happen because of hardware differences, constant factor, and hardware optimization. The conclusion clearly states that binary search works in a logarithmic scale and it is highly efficient for large, sorted, and datasets. This part uses directed graphs to study who follows whom and how information and group from one's social media.
Hello, this is Mahi. This page explains the introduction and methodology of following graph analysis. A following graph is a directed graph. This means the connection goes in only one direction. For example, on social media, one user can follow another user without being followed back. In this study, the graph was created using a connection matrix, which shows the connections between users. The networks were created with 500 to 2500 nodes. The directed connections were added randomly with a probability of 0.1 and self-loops were not allowed. Finally, the analysis focused on in degree, out degree, total number of edges, and connected components. This page presents the result and analysis of the following graph. According to the explanation, the result confirms the handshaking lemma, which states that the total in degree equals the total out degree, both equal to the total number of edges. The page also discusses weakly and strongly connected components, explaining how connectivity differs in directed networks. These results help understand how information spreads in social media. This page contains the final conclusion of the following graph analysis. As written in the PDF, the analysis confirms fundamental group theory principles. It explains that while information can transfer through most of the network, Due to weak connectivity, strong connectivity is limited to small groups. This finding provides insight into real-world social media platforms and their impact on information sharing and community formation. Thank you for listening. I am grateful to our teacher and our group members for their support. Thank you once again.